Hooray! I have the keys to unlock Pocket Ronnie. Okay, in the last lesson we had polar coordinates. Polar coordinates were with r and theta. And so now I'm going to be going into introducing polar equations. Polar equations will be equations using r and theta. Okay, what you have done already is rectangular equations. We're using with rectangular coordinates x and y. So here I'm just going to go through this refresher really quick of these equations. A line will look like this in the form of y equals mx plus b, or it could be in standard form. But a line, neither y nor x is squared. In a circle, both x and y are squared. X squared plus y squared equals 9, or it could be in this format right here. Okay? Ellipse. Both x and y are squared, but they have different coefficients. That's how you know it's an ellipse. Parabola. One will be squared, one is not. Here, this is an up and down parabola. Parabolas can also be facing right and left. Y equals x squared, that'd be facing up. This one is facing down, and it would also be shifted up too. Hyperbola. This is just one format of a hyperbola to where x and y are multiplied together. In a line, x and y are added together, but in a hyperbola, x and y are multiplied together. And a hyperbola has two parts to it, mirror images of each other. Okay? So what we're going to be doing is we're going to be converting rectangular equations into polar equations. Instead of having x and y, we will now be having r theta. How do we do that? Let's just say we have a point right here that's an x and y coordinate. Okay? We can draw a line from the origin to that point. We can make a right triangle from all of that. This was my x, because I go straight over in the x direction, then straight up. That would be a right triangle. We are going to call the hypotenuse r, and then you have some angle theta here. We did this when we were converting polar rectangular coordinates to polar coordinates and vice versa. Since we're going to be converting rectangular equations into polar equations, we need a relationship between x and y and r and theta. Okay, so looking at this triangle here, so how can we use trig functions with theta and x and y? Okay, we can say that cosine theta is adjacent over hypotenuse, and in this case it would be x over r. And if we multiplied r to each side, then essentially we will have x equals r cosine theta. That is one relationship that we're going to use. For y, sine theta would be y over our hypotenuse, multiplying r to each side. Then we can say y equals r times sine theta. That is another relationship we will use. Then, if we know x and y, how can we relate that to r, which is hypotenuse? That'd be Pythagorean theorem. X squared plus y squared equals r squared. This is the third relationship we will use to convert rectangular equations into polar equations and vice versa.